Hey gang, Mr. Rising back again. Today we're looking at section 3.2, which is parallel lines and transversals. So what your objective for the day is prove and use theorems about angles formed by parallel lines in a transversal. Big idea. And right off the bat, they're going to drop a postulate on you. And here's the postulate. 3, 2, 1. If two parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. And so what we said before in the last section was, oh, northwest corner, those are corresponding angles. Well, if my lines are parallel, then those angles are congruent. And if you look here, you can see that there's all these beautiful relationships that form of corresponding angle pairs that are congruent. So my question for you is what kind of logic is this based on? Is this based on observation, or is this based on deductive reasoning? And of course you're thinking to yourself, well, clearly they've gone out and measured every single pair of corresponding angles formed from parallel lines, and they're like, well, yeah, they've got to be. No, it's deductive reasoning, because if these angles and these angles are supplementary, then of course angles 1 and 3 have to be congruent. Very, very interesting. All right, so first thing we need to do, recognize from this postulate, is that anytime you see these little arrows, it means this is a pair of parallel lines. Again, so these arrows here are parallel lines. And let me just jump back for a second. You have an assignment to get all the postulates and theorems into your book. So hey, here's the first one, start off. And again, arrows mean it's a pair of parallel lines. And you'll see examples where you've got multiple arrows in just a moment. Okay, find the measure of angle QRS. Let's see, QRS. Oh, wait a minute. So this angle here is congruent to this angle here. So X is 118. So if I'm trying to find this angle here, QRS, sorry for the sloppy line, that's just going to be 180 minus 118, and 180 minus 118, let's see, 18 from 80 is 62, right? 62 degrees. My math look good? 70, yeah, that works. Next question, or comment. If a transversal is perpendicular to two parallel lines, then all 8 angles are congruent. And that makes perfect sense. So again, if you're saying this line here is parallel to this line here, oh man, I shouldn't have done that. Let me go back. Sorry, gang. Let me make it a little easier. Transversal. If a transversal is perpendicular to two parallel lines, then all 8 angles are congruent. Okay, of course you've got vertical angles, and they have to be supplementary, so you can just put beautiful boxes around all of these. It's pretty cool. Awesome. All right. Remember, postulates are statements that are accepted as true without proof. Since the corresponding angles postulate is given as a postulate, it can be used to prove the next 3 theorems. So these theorems are in your book. They're on page 156. I do want you to get them in there. So this is page 156, theorems. I like them how they do them in the book as opposed to the back of the book, because they give you the picture and the example with it. And I think it's really important. So 3, 2, 1, corresponding angle postulate, and the next one have to do with alternate interior angles are congruent, alternate exterior angles are congruent, and same side interior angles are supplementary. So you're going to use those throughout the rest of the chapter and the rest of your lives on applying those concepts elsewhere. Let's try a couple of more problems. So again, real quick before we move on, please make sure you get the this postulate, corresponding angles postulate, and the theorems on page 156, also known as alternate interior angles, alternate exterior angles, and same side interior angles are supplementary. Congruent. Cool. Let's try this one. I'll try to make this video short. It says find the measure of angle ABD. And I think this is really important when you look at these diagrams to say, what in the world are they talking about in the first place? Well, first of all, this little angle here, angle 1, is 2x plus 10. And this little angle 2 is 3x minus 15. These red arrows, of course, indicate that the lines are parallel. So you'd say, oh, Mr. Rising, well, of course, this angle 1 is congruent to angle 2 because of why? What kind of angles are they? And you'd say, oh, because of the theorem alternate, why did that work? Alternate interior angles are congruent, right? Alternate interior angles are congruent. Well, what does it mean that angles are congruent? Well, if angles are congruent, that means that they have the same measure. Well, if they have the same measure, you can set them equal to each other. So here it is. 2x plus 10 equals 3x minus 15, and then it's simply an algebra problem. I've got 3x's on this side. I'm going to move the 2x's over. I've got 10 over here, so I'm going to move this 15 over there. How do you do those operations? We'll take the opposite. So let's subtract 2x from both sides and add 15 to both sides. And that gives you a nice simple x equals 25. Well, hey, are we done? No way. You got to plug 25 in for x, and you can plug it into either equation, and you find out that that is actually equal to 60. All right, next one. Find the measures of the acute angles in the diagram. Now, before you start running down this problem, be very careful of something, and here's what I want to point out. Read the question again backwards. Diagram the in angles acute of the of measures the find. What? What I heard was acute angles. So it wants you to find the measures of the acute angles. Well, wait a minute. Which angles here are acute? Let me grab my pen. Well, check this out. If this angle is 125, that's an obtuse angle. This is an acute angle. And this is an acute angle, and this is an acute angle. And of course, vertical angles are congruent. So I know all these angles right here are exactly the same. So wait a minute. This whole thing about 25x plus 5y has nothing to do with the problem. Okay, so be aware of that. All this here, yeah, you can use this to solve x and y, and I'm going to do that in a moment. But first of all, answer the question. Right? It says find the measures of the acute angles. The next thing it says, well, I mean, that's one acute angle. The other one is this angle right here, and I'm going to denote it with 2 arc marks because all these are congruent, right? So all these corresponding in vertical angles also have the same measure. And when you do this problem, you're like, wait a minute. This is like really easy. Why? Because of a linear pair theorem. So this red angle is just simply, wait a minute, 180 equals 125 plus the red acute angle, right? So red equals 180 minus 125. Say it again, say it together, 55. Very good. Well, that means this other angle, the blue one, and that means the blue angle is equal to 180 minus 120, and that's equal to 60. So really, that's an easy problem. Now, if you looked at these values and said, wait a minute, solve the value for x, that is a whole different problem. And I want to just take a quick moment to do this because we're going to talk about systems of equations on Friday. So here it is. If the problem now said, forget the acute angle, solve for x and y. So we're going to just scratch this out. Find the measures of scratch that out, x and y. Oh man, now you got to deal with these. So what this means, find the values of x and y. Well, 125 corresponds to this angle here. And because these are vertical angles, that means that 125 equals 25x plus 5y. Just slide that down like that. And 25x plus 4y equals 120. So I've actually set up these two equations. Now, this is what we're called a system of equations because you've got two variables you have to solve for. And so we're going to try to find a working solution. Now, they made this problem pretty easy for you because if you notice, you have a 25x in both problems, which means when we do systems of equations, you can eliminate, you can substitute, you can subtract, you can graph them, you can do all sorts of things. But take a look at this. If I just subtract this equation, 120 equals 25x plus 4, from 125 equals 25x plus 5y, if I subtract the two, the x's fall out, and I get 5 equals y. Well, that's really cool because then I can take 5, plug it back into either one of these equations. I chose this equation right here, and I get 5 times 4 is 20. So now I've got the equation 120 equals 25x plus 20. I'm going to subtract 20 from both sides, and that makes 100 equals 25x. Divide both sides by 25, and x equals 4. So just be aware, we can do these kinds of problems, but it doesn't mean you have to do them to answer the original question. So don't get freaked out when you see some crazy looking graph like this. First of all, read the question backwards and see if it helps. And if it does, hopefully that kind of brings it home to you. All right, just to recap here, today we want to do prove and use theorems about angles formed by parallel lines and transversals. We're going to do proofs with this later on. We're going to do these together. But I think the big idea is recognizing what angle relationships are congruent, which ones are supplementary. Which ones are supplementary? That's right. Same side interior angles are supplementary if the lines are parallel. We're going to hit this harder on Friday, and then if you have any questions, please just email me or let me know.